Hello everyone, this is DSA Zindabad. Today we are going to solve the 17th question of Arsh Goyal DSA sheet. And the question is spiral matrix. Now let's look at the question. Given an M cross N matrix, we need to return all the elements of the matrix in spiral order, right? Basically, we'll be having M cross N matrix. From this, we need to return all the elements of the matrix in spiral order. What do we mean by spiral order? It will be something like this, right? This will be a spiral order, right? Now let's look at the example, right? We have given this matrix. So from this, we can directly say this will be a spiral, right? So from this, we can directly return all the elements as 1, 2, 3, 6, 9, 8, 7, 4, 5, right? So this is our answer in a spiral order, right? Now let's look at the second example also. So from this, you can directly see the spiral order would be something like this, right? So from this, the element will be 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, and 7, right? This will be our answer to this example, right? So now let's jump into the approach and try to figure out how we can solve this question, right? Approach, right? So this is our matrix, right? So whenever we need to have a spiral order, right? We need to return all the elements from the given array in a spiral order, right? This is our main goal. So just try to observe the pattern. Like we are moving in this way, right? Just try to look at the pattern and try to guess the number of rows which will be affected by each and every iteration in the spiral, right? Also look at the columns also, right? What do I mean? This will be clear. Let's say initially we need to traverse throughout this row. Let's do this step by step. So first of all, this will contain 1, 2, 3, 4. When we traverse over this matrix linearly over the first row. So initially, this is a 0, 1, 2, 0, 1, 2, 3, right? Initially, we are moving across the first row, which is 0 over there, since we assume zero-based indexing in the matrix and aggregation. So let's say it will be 0. We are moving across the 0th row initially, and column varies from 0 to 3, right? So now, after this, this is our first thing. Second thing, when we move down, what remains constant? Like for down, this is our right, and this is our down. So for down, as you can see, row varies from 0 to 2, right? 0 to 2 for row, and for column, this is for column, and for column will have the same column over there, which is 3, right? So now third thing, we'll move left, right? So the row will be constant, which will be equal to 2, and the column varies from 3 to 0. So now just look at this, when we move from right to left, our order of column changes from 0 to 3 to 0 to 3 to 0, right? Like its order will be reversed as that in this case, like when we move to right and when we move to left, right? So now after this, we'll move upwards, right? Fourth condition can be upwards. In this case, row will vary, which varies from 2 to 0 in the reverse order as that of the down case, right? And the column will be remain constant, which will be 0. So now, as you can see, in each and every movement, whether we move right, down, left, up, right? So there are four possible movements which we can do across this matrix, right? Which will be up, down, right, and left. These are our four movements which we can like move across this particular matrix, right? So now after this, when we traverse over the all the edges of the matrix, for the initial zeroth row, third column, and like in this way. So after this, we need to consider these two elements also, right? These two elements also. So now just look at this. After this, what's the change over there? After this, our row is incremented to 1 and R, right? So there is a change in the row over there, right? Because initially you can see initially we are at the extreme end of the column and the row also. What do I mean? Initially, this is the beginning of the row, which is 0. This is the extreme left value, and this is the extreme right value. And same goes for column. This is the extreme left value, and this is the extreme right value. So after this, initially, our matrix is something like this, which is of size m cross n. So after covering all the edges of the matrix, we need to consider this matrix. So our matrix will look something like this, which will contain 6 and 7, right? So how, I guess all of you guess, till now, all of you guys understand what I'm trying to say. Initially, we'll be having 4 pointers. Why 4 pointers? Because we'll try to reduce the value and increment the value accordingly as per our problem. Initially, we'll be having, let's say, we'll be having row begin, and this will be our row end, and this will be our column begin, and this will be our column end, right? So we'll have 4 pointers, right? With the help of which we can move across our matrix in a spiral order. And uh, like uh, for the four cases, initially, let's say, there are four choices over there. Four choices. Either we can go up, either we can go down, either we can go right and left. There are four possible movements which we need to do in order to return all the elements in the spiral order, right? These all are the movements. And for this, we have initialized 4 pointers, which are row begin, which will be pointing to the initial row, which will be 0, and the row end, which will be pointing to m minus 1, considering m are the number of rows and n is the number of columns, right? And there will be column begin, which will be 0, and column end, which will be n minus 1, right? So we'll have these 4 pointers to iterate over the matrix, right? And after each and every possible movements, what do I mean? Let's say whenever we have this movement, which is, let me just write this thing for you. Whenever there is we are traversing in right direction. In the right direction, in this direction, what are the constraints? So for this, our row begin will be as it is, right? And our column will be varied. So this is our column, which will be varied. So for this, our row is constant whenever we make movement in the right direction, right? So after this, so whenever we move in the right direction, we need to consider the second row. What do I mean? When we traverse over this row, so we need to increment our row begin, so that after traversing these elements, which are 1, 2, 3, and 4, we need to traverse 6 and 7 also, right? So for 6 and 7, we need to increment our row begin, right? So after this, what we need to do? We need to increment our row begin, right? So now let's talk about the second moment, which is down. So for down moment, as we can see, like from the matrix itself, like for the down moment, our column will remain as it is, right? Our column will remain as it is, which is column end over there, right? So our row will be varying over there and column end is constant, right? So after moving in the downward direction, like in this direction, we can see like we already considered these elements and also these elements. So after this, we need to consider this element. So in order to do so, we need to decrement our column end, right? So that column end will be pointing to this element. So for this case, after like movement in the downward direction, we need to decrement our column end, right? Now let's talk about the third movement, which is left movement. In this case, our row end will be something like this, and our column will vary, right? And after this, what we need to do, we need to decrement our row end so that this will be pointing to this row. Our row end will be pointing to this row, right? So now let's talk about the fourth direction, which is upward direction. So for this, we'll have J and column begin, right? Our row will vary now in the upward direction, right? So for upward and like downward, our row vary, and in case of like left and right, our column varies, right? Now after there is a upward movement, our column begin will be plus plus, right? And all of these four movements will remain until row begin is less than equal to row end, right? And then same condition goes for the column begin and column begin and column end. I hope this approach is clear to all of you guys. You just need to figure out the pattern and you just need to figure out like how you are traversing over the matrix. Like as you all can see, like we just find out like there are a total of four moments. So for all those four moments, we require four pointers, which will be row begin, row end, and column begin, column end, right? And after this, we'll just solve the question, right? Now let's try to code this thing up. So initially, int m will be equal to the number of rows which will be have, and int n will be equal to the number of columns in the matrix. So we'll initialize a vector to store the spiral order, right? So after this, we'll initialize all the four pointer which will have a row begin being pointing to the start of the row and row end which will be pointing to m minus 1 because m is the number of rows over there, and column begin which will be 0 and column end which will be n minus 1, right? Now we'll run our loop until row begin less than equal to row end and end column begin less than equal to column end, right? Now first movement is traverse right. So for right, as we all know, like our column will vary and our row will remain as it is. In j will be equal to column begin, j less than equal to column end, J plus plus. After this, we just need to push this thing into our vector matrix row begin and J, right? So after this, we need to increment our row begin. So after the right movement, we need to have a down movement. Int J equals row begin J less than equal to row end J plus plus, right? We just need to push this thing into our vector, which will be matrix. So in case of down movement, our row will vary and our column will remain as it is. So after this, we need to decrement our column. So after this, we'll have a left movement. Before left movement, we'll need to check if row begin is less than equal to row end. This is for the overflow condition, like index out of bound, right? So after this, G equals column end. Whenever there is a movement from left to right, like there is a left movement over there, so J is greater than equal to column begin, right? Because we are traversing in the opposite direction as that of the right movement. So that we push this thing into a vector matrix row and G, right? After this, we just need to decrement our row and now there is a upward movement. And for upward movement, we also need to check if our column begin is less than equal to column end, then we need to iterate int J equal row end and J is greater than equal to row begin and J minus minus. And we'll directly push this thing into our vector matrix J and column begin, right? So after this, what we'll do, we'll need to increment our column begin, right? So after this, this is all the moment are done. After this, we just need to return our vector, right? Now let's try to run this code. Yeah, this runs perfectly fine. Now let's try to submit this code. Yeah, it runs perfectly fine, right? Now let's discuss the space and time complexity for the scene. So now let's discuss the time and space complexity for this, right? This will require these both. These four loops will require big of n, and this will require big of m. So ultimately, our time complexity will be something like this: big of m cos n. If we consider m to be equal to n, this will be equal to big of n squared, right? And the space complexity will be big of 1 since we are not using any extra space, no extra space. I hope this approach is clear to all of you guys. Please do a dry run by yourself so as to have a better understanding, right? Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.